Hey everyone! In this video, we're diving into the world of biopesticides and exploring how these eco-friendly solutions are changing the game in pest management. We'll be breaking down what they are, what types are out there, and the pros and cons of using them, all while looking at some real-world examples. Let's begin by understanding what biopesticides are and how they differ from conventional chemical pesticides. Next, we'll explore the three main types of biopesticides. Then, we'll discuss their advantages and the challenges they face in real-world use. Finally, we'll look at inspiring success stories and how biopesticides are being adopted around the globe. Biopesticides offer an environmentally safe alternative to traditional chemical pesticides. This section defines biopesticides, highlights their origins, and emphasizes the importance of eco-friendly pest control solutions. Definition and origins of biopesticides. Biopesticides are nature's own tools for pest control, derived from sources like microorganisms, plants, and minerals. They've been used throughout history in different forms to protect crops, long before synthetic chemicals ever existed. Unlike traditional pesticides, they're designed to target only specific pests, leaving beneficial insects, animals, and humans unharmed. Rooted in nature and refined by science, biopesticides offer a cleaner, smarter way to safeguard our food and ecosystems. How do biopesticides stand apart from chemical pesticides? For starters, they're biodegradable, breaking down naturally and leaving little to no environmental footprint. They also offer targeted pest control, focusing on harmful species while protecting beneficial insects and supporting biodiversity. And when it comes to safety, biopesticides generally pose fewer health risks, making them a safer option for both people and the planet. Designed with nature in mind, biopesticides bring together effective protection and sustainable farming, helping us grow more while harming less. The three primary types of biopesticides. Biopesticides play a vital role in sustainable farming, offering precision, safety, and protection for biodiversity. They come in three primary forms, each with its own unique function. Microbial biopesticides rely on living organisms, like bacteria, fungi, or viruses, to manage pests naturally and effectively. One of the most well-known examples is Bacillus thuringiensis, or BT. This bacterium produces toxins that specifically target harmful insect larvae without affecting other organisms. Thanks to their precision and natural origin, microbial biopesticides like BT have become a trusted solution in sustainable pest control. Biochemical biopesticides work by influencing pest behavior rather than killing them directly. For example, pheromones are used to disrupt pest mating cycles, reducing populations in a natural, targeted way. Another example is neem oil, a plant-based extract that repels pests and slows their growth, all without harming beneficial organisms or the environment. These substances offer a gentle yet powerful approach to pest control, perfect for sustainable and eco-friendly farming. Plant-incorporated protectants, or PIPs, are pesticidal substances produced by genetically modified plants. By inserting specific genes, these plants develop their own resistance to pests, reducing the need for external pesticide applications and supporting more sustainable crop protection. However, because PIPs involve genetic modification, they are not permitted in organic farming. Still, in conventional agriculture, PIPs offer an effective and targeted solution for managing pests with reduced environmental impact. While biopesticides provide numerous benefits, they do come with some challenges. Addressing these obstacles is essential to fully harness their potential in sustainable agriculture. So, let's take a closer look at what these challenges are. Biopesticides generally have a shorter shelf life than conventional pesticides, which means timing their use carefully is important to maintain their effectiveness. They also need specific storage conditions, like controlled temperature and humidity, to preserve their viability. These requirements can pose logistical and economic challenges for producers and farmers, affecting how easily biopesticides can be stored, transported, and applied in the field. Biopesticides' effectiveness can be influenced by environmental factors like temperature, humidity, and sunlight. Fluctuations in temperature may change how well they work during application. Humidity also plays a role, affecting their stability and ability to control pests. Additionally, exposure to ultraviolet light from the sun can break down biopesticides, reducing their potency. Because of these sensitivities, precise timing and conditions are essential to achieve the best results. Compared to chemical pesticides, biopesticides typically work more slowly to control pest populations. This slower action means that farmers need to be patient and carefully monitor their fields after application. Timing is critical. Applying biopesticides at the right stage of pest development or at optimal environmental conditions greatly improves their effectiveness. To achieve the best results, biopesticides are often used alongside other pest management methods, reducing the need for chemical inputs. This integrated approach supports sustainable farming by balancing effective pest control with environmental safety. Biopesticides are being embraced around the world, with many success stories highlighting their effectiveness across different crops and climates. These examples show how biopesticides can play a vital role in moving agriculture toward more sustainable and eco-friendly practices. In India and the U.S., Bt-based sprays have successfully controlled caterpillars in corn and cotton fields, reducing crop damage and improving yield. Farmers often report fewer pest outbreaks, improved soil health, and better long-term sustainability when combining biopesticides with crop rotation and trap cropping. Successful applications of biopesticides in European agriculture. Biopesticides are increasingly being adopted throughout Europe, particularly in countries with well-established organic farming industries such as Spain, France, and Italy. A standout case is in southern Spain, where tomato farmers have effectively employed Trichoderma spp, a microbial biopesticide, to combat damaging soil fungi like Fusarium and Pythium. These pathogens attack the roots and can significantly lower crop yields. By applying trichoderma to greenhouse soils, growers have boosted plant health and cut back on chemical fungicide use. This method not only improves the quality of the tomatoes, but also complies with the EU's stringent pesticide residue standards. Incorporated within integrated pest management systems, this strategy supports Spanish producers in meeting the export requirements of major organic markets, including Germany and Scandinavia. Around the world, governments are strengthening support for biopesticides through favorable regulations and policies. At the same time, consumers are increasingly seeking safer, environmentally friendly food options, driving demand for these natural pest control solutions. Advances in biotechnology are further improving biopesticides, making them more effective and diverse. Together, these trends are helping biopesticides become key tools in the future of sustainable pest management. Final thoughts. Biopesticides represent a promising and eco-friendly alternative to traditional chemical pesticides, offering effective pest control solutions that prioritize environmental safety. Their ability to target pests precisely while minimizing harm to beneficial organisms makes them an important tool in sustainable agriculture. However, to fully realize their potential, it's crucial to overcome challenges. With continued innovation, supportive regulations, and increased awareness, biopesticides can play a central role in advancing sustainable pest management worldwide, helping to protect crops, ecosystems, and human health for future generations.